The broadcast is now starting. All attendees are in listen-only mode.
Okay, I hope you can hear me now. Let's start again. Apologies for those who haven't heard me before. Can you hear me now? This is a webinar on the safety law. As you know, the publication of the iChemist Safety Center on lessons learned from. Perfect, thank you so much. On the lessons learned from accidents. And as you may know that we have already covered 3 topics in this safety law. First of all, we covered startup accidents, then maintenance of atmospheric storage tanks, and then the third one covered flare systems and flare failures. Today's topic is lessons learned from aging. aging assets, aging of establishments. What I have said before, but unfortunately something happened to my microphone, so you couldn't hear me, is that I would like to kindly ask you, as it was the last time and it worked perfectly, I believe so, that you can share your comments, your suggestions, and your questions and ideas in the question box. So last time, many of the attendees were really great in sharing their experience and their knowledge, because what is the main point here? The main issue and the main goal with this webinar is to share knowledge, to share information, and learn from each other. So if you feel that you would like to share something that I may not cover within the safety law, because it happens, then please feel free to add your comments. And if you have any questions, you can even answer to each other, because that is really brilliant when you share your practice, your experience with others. So how I come to this topic and what is the background, so that I used to work as a Seveso site inspector for approximately 10 years or so, and then I did research activities within the European Commission's Joint Research Centre at the Major Accident Hazards Bureau. Now, at that role, I was also involved in the OECD Working Group on Chemical Accidents, which was a great experience. Why I'm mentioning it? I'm mentioning both of them because, first of all, the OECD Working Group on Chemical Accidents, we published in 2017 a very good report on aging. And we analyzed accidents in that particular report and what authorities can do about how they address aging. And I know for sure that some of the my colleagues from different organizations, regulators are here today, which I'm very grateful for. So that's why also I'm mentioning it. The other one is that at the Major Accident Hazards Bureau, we also published lessons learned bulletin on aging. Let's jump into the topic now. And I think this is not new, what I will tell you about, that was published by the UK Health and Safety Executive. And I think that everybody uses this definition worldwide, because this is a really valid and complete definition of aging. Because aging of industrial facilities, aging of assets is a well-known phenomenon, first of all, and it has a broader implication that goes far beyond corrosion management that we all know. And it is sometimes mistakenly believed that aging is about how old the establishment or the equipment is. However, aging of industrial plants has a wider meaning, and it indicates the degradation of the equipment in use, its overall condition, and the change in its condition over time. So basically, everything associated with a site and its processes can age. So we are not talking only about physical aging, but also aging of processes, so that not only equipment but people, procedures, and technologies can age. These physical states, mechanisms, organizational elements can lead to major incidents. As you may know, that I normally cover 2 case studies within the safety law, analyzing those cases, describing the story, and then drawing some key learning points. And in the end of the 2 case studies, I come to the second part of the safety law, which is the what can I do session. That is, what can I do as a manager, as a supervisor, process safety engineer, and what can I do as an operator in my job to avoid that further similar accidents occur in the future. I would like to highlight that even though I try to capture all information that is possible within the safety law, it's just not possible to cover everything. So if you have additional ideas, that's why I encourage you to put in the question box, because this is also really valid that you bring into this picture and the discussion and the dialogue from your practical experience. Now, another question that was asked in the last webinar and even before that, if I want to share pictures, apologies, but I don't share pictures because you can find many pictures of ruptured pipelines and tanks that collapsed or explosions or vapor cloud explosions or fires and so on the internet. So I don't want to repeat those pictures, and also there is copyright issue behind. So, and also the PIDs may be useful, I agree, but not all the reports are coming with PIDs, and so I can't share those with you. Now, let's talk about the first case. It occurred in 2012 in August, where a catastrophic loss of containment occurred on an approximately an 8-inch diameter piping, which was associated with the gas oil side draw on an atmospheric crude distillation column in a refinery. The pipe ruptured and released flammable hydrocarbon process fluid to the environment. Now, the flammable liquid partially vaporized into a large vapor cloud, engulfing 19 employees. After 2 minutes, the flammable portion of the vapor cloud ignited. Luckily, all the employees escaped, narrowly avoiding serious injury. Let's see now the key learning points. The underlying cause of the pipe rupture appears to be poor maintenance procedure in regard to mechanical integrity. Subsequent testing determined that the rupture was due to pipe wall thinning caused by sulfidation corrosion. In fact, over a period of nearly 35 years, the 52-inch long piping component had lost on average 90% of its original wall thickness in the area near the rupture. Although the company employed experts in sulfidation corrosion, they were not consulted on any key decisions associated with potential sulfidation risk of the crude distillation unit. Now, this actually raises some questions here, because the next law, I will be covering a very interesting topic. It's about creeping changes. So one aspect of this particular accident is coming from that point of view, because as you could see that the thinning of the pipe in question happened over a period of nearly 35 years. That is quite a significant time, isn't it? And then the other issue is why the company didn't consult with its experts. So that also it's an organizational factor here that you can pick up. Let's continue the key learning points. The crude distillation unit is one of the processes most associated with sulfidation corrosion in petroleum refineries. However, the process hazard analysis of the crude unit didn't consider the potential for sulfidation corrosion. So there was a lack of hazard identification here. The pipe in question was made of carbon steel, which had a tendency to corrode from sulfidation faster than typical higher chromium containing steels. In addition to that factor, carbon steel also experiences significant variation in corrosion rates due to possible variances in silicon content, a component used in the steel manufacturing process. Carbon steel piping containing silicon content less than 0.1 weight% can corrode at accelerated rate up to 16 times faster than carbon steel piping containing higher percentages of silicon. So this should be considered in the risk assessment. So there's a lot of scientific information behind that would be really useful if operators knew about in this case. And what I also mention always in my webinars is that even though these cases have so many recommendations and learning points from different aspects, I try to cover only that very, very narrow field that is the topic of the safety law. So even though you may recognize the case and you know that there are so many other aspects, yes, they may be, and there are actually, but I try to focus on this very specific topic on aging this time. Let's come to the second case. Now, this is a very interesting one, and you can find it also in the OECD report, all I have to say. In 2005, and okay, now that I mentioned the OECD report, it is freely available, and I give the resource information in the end of the webinar. So, in 2005, a storage tank containing 16,000 tons of 96% sulfuric acid that actually ruptured. The content of the reservoir spilled out into the bund and then the dock. The remaining 2,000 tons of acid in the bund came into contact with salt water that actually created an exothermic reaction, which produced an acid cloud consisting of hydrogen chloride. The vapor cloud drifted along the coastline and mostly over the sea. And luckily, no one was affected by this event. So what caused the leak? The incident was caused by a leak in the cooling water supply pipe passing under the tank farm. The leak undermined the ground under the foundations of the tank, which then ruptured because of the uneven weight distribution, resulting in the sudden release of the acid. The bund was filled with salt water when the rupture occurred, and that caused the formation of hydrochloric acid. So many underlying causes here we already see. The uneven weight distribution plus the salt water in the bund. Apparently, so the pipe was made of concrete and came into use in the early 1960s. The only damage noted to the pipe was a leak at the pumping station in 1999. So no problem was actually discovered until the point in 1999, since the 60s. The inspection of the failed pipe following the incident detected little or no internal corrosion, but heavy external corrosion to the concrete. In certain parts of the pipe, the concrete has corroded so severely that the reinforcing steel had also been exposed. It suggests that the corrosion was as a result of an acid attack on the concrete. According to the standards, a strong acid attack on concrete occurs if the pH level in surrounding water is less than 5.5, and a very strong attack occurs if the pH level is less than 4.5. Now, the company drew the conclusion, and this is an interesting part, that the pH level that was measured in the shallow groundwater in 1989 was measured as 4. So you see, it was way below 5.5, where an acid attack on concrete occurs, and even below pH level 4.5, where very strong attack occurs. So the company measured it in groundwater in 1989, and it entailed risks for strong acid attack on the concrete. However, there was no risk assessment conducted. So this is the time when I usually come to the point that what can I do? And this is a key part of the safety law. There was a question. Yes, it was an underground pipe. Yes, it was underneath the tank foundation, and yes, it was an underground pipe that was exposed to water. It was exposed many environmental circumstances, and that's where it occurred. So a key part of the safety law is understand what you can do at your facility based on your role. And this is always I show you, I know, but may some of you not being here, I try to explain. So this is what you can see on the picture is the 6 elements framework that the iChemist Safety Center follows. It is not a safety management system, doesn't seek to replace one. It is an agreed framework by the companies that form the members of the iChemist Safety Center, that agreed on the 6 really important elements, such as systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. And all of them are underpinned by one really key element, which is leadership. Leadership must be everywhere on these areas. And so that the apologies. The iChemist Safety Center believes that leadership across these 6 key functional elements is vital, and this is a basic for understanding and achieve good process safety outcomes. So as you can see, all these elements are associated with the color code. And what you can see in the safety law that is published on our website in PDF form, so you can free to download all these publications and share with all your communities, all your clients, colleagues, everybody that you wish to. Those color dots are associated with each recommendations within the What Can I Do session. What we have discovered, and this is why we established the What Can I Do session in the safety law in this way, is that lessons learned bulletins and lessons learned publications are really valued and really great that are published by other institutes. But sometimes we felt that it's like a bulk lessons learned, so that you can't know what is your role, what elements actually are within your ownership. So that's why we try to do something different and separate lessons learned and recommendations based on your role. So what can I do as a manager in this case relating to aging? And as I said, you may feel free to add more on these recommendations. Now, in the What Can I Do session, I go beyond the 2 case studies. It is not simply a reflection on those studies. It will cover many other aspects from coming other accidents that I researched and analyzed regarding this topic. So, as a manager, ensure that lead process safety metrics are implemented to address aging phenomenon in the operation. And I have to stop here again because at the iChemist Safety Center, we have published a guidance document on lead process safety metrics, and it is free to download from our website or together with other guidance documents that are freely available. So I encourage you to visit our website, which I give you in the end, and try to find all the guidance documents that you may want to use or you may want to check for your operation. Now, what else? Identify and monitor signs of aging, in particular corrosion, erosion, fatigue, creep, obsolescence. So corrosion, erosion, fatigue, creep, obsolescence. Ensure that policies are in place for determining the end of equipment life. Plan a life cycle for the plant and the equipment, and have a date for retirement or replacement of them. Make sure the company has clear, up-to-date procedures and instructions available to cover normal operating, emergencies, and management of change. As you may remember in the beginning, I told you about aging is not only physical. It's not only about the equipment. It's not only about the tools. It's also about procedures and also about people. And so that's why it's important to keep everything up to date. have a systematic inspection program in place that addresses aging phenomenon in order to monitor condition of the plant and equipment or handle inadequate design. Have complete documentation on the history of all safety critical equipment, including use parameters, changes, and additions since their installation. You may be quite surprised, or you may not be, I don't know, but I was quite surprised when I analyzed many accident reports, and apparently many facilities didn't have any archive documents about the original design, the original documentation of these safety critical equipment. So and also what were the pressures, what are the temperatures that they started operating, and so that is really important too, because if you don't have the history, you can't see what's happening over the years. And this will come up in the next law, in the creeping changes more precisely. I just wanted to highlight that it's already an aspect here at aging. As you can see, the managers can do a lot of things. So let's see what else. So have up-to-date documentation of all the safety critical mechanical equipment, such as tanks, pipelines, pumps present on the site, including all component parts, and it includes replacements, additions, you name it. Address aging of critical assets such as primary containment systems, control and mitigation measures, electrical control and instrumentation systems, and structures in the aging inspection program. And here comes the factor of people. Ensure that key skills, knowledge, and experience that are relevant to asset integrity management and aging is transferred and maintained with people leave or retire or move to a new position in the company. And as you know, that this is a key aspect, so that you have to think about transfer the knowledge and have the people with the right skills, knowledge, and competence. I already mentioned the guidance document on competency, but you can check if you want to. Then make sure that process knowledge is maintained and transferred. Also make sure that incident investigation reports highlight causes and lessons learned related to obsolescence and loss of knowledge. Because what I've discovered over the years was that many accident reports actually didn't address any further than technical failures. And that's why it is important that when you investigate any accident, then try to go beyond and analyze the underlying factors and contributing factors or root causes or whatever you call them, but go beyond the technical failure or the physical failure and try to figure out what were the organizational aspects and the management system, and what other key issues that you can discover about the accident. Then you will have a better understanding of why it happened, because that is the important issue here, that you want to know why, all the why questions. And another lessons or recommendation for the management is degradation. Oh, apologies. There is one more. Make sure that staff and contract workers engaged in maintenance and change operations have access to all relevant documentation, because sometimes they don't know why they are doing what they do, and they don't know what are the circumstances when they start working. And degradation of the equipment should be subject to hazard identification and risk assessment. This is something like a repetition, but it's better to repeat, because then it is part of the learning process. Now, if you are a process safety engineer or a supervisor, then what are the recommendations for you? You also have a couple of aspects here. What I would like to highlight is and I always tell this, but I think it's important to repeat that even if you are a supervisor, even if you are an operator, you may want to read also the aspects and recommendations that are valid or subjected to the managers, so that you are aware of all the aspects, not only your roles, but also others, even though you focus on your ownership in the particular topic. So, as a process engineer or supervisor, make sure that underground piping that entail risks to foundations are inspected and measured. So this is also the answer to the question that that was an underlying underground pipe. And some of you asked if it was insulated. I don't have any knowledge about that. From the report, it wasn't clear whether it was insulated or not. But I can guess that it wasn't, but I don't want to guess, okay? Ensure that all safety critical equipment fit for purpose and is documented. You have to document everything, because that is a foundation of a good archive system and the knowledge that you have and hold for years. Composite materials can be subject to degradation mechanisms if not properly installed. Make sure that material selection is completed by corrosion experts reliant on service experience and advice from equipment manufacturers. That is a key role. Manufacturers have a key role in this as well. What they give you and whether they give you all the recommendations and the features of how to set up, how to install that particular equipment. Because if you don't install it in a correct way, then it degrades, start degrading pretty early, which is called premature aging. So that is an aspect to consider. And I know that in many accident reports, actually manufacturers didn't provide with all the information necessary. So that's why the operators didn't know how to set up certain valves or certain, such as padlock, whether you need a padlock or not. And that's why it's a key that you have to have all the features provided by the manufacturers. What else? Pay attention to the potential aging of safety critical electrical, control, and instrumentation equipment and systems in terms of physical and performance degradation. Make sure that old or obsolescent equipment and systems are recognized and managed with special care of spares, repairs, and competencies for modifying or checking older software and logic-based systems. And this is really interesting, I have to say, because it's also related to the topic of creeping changes, where you have to consider when you change anything in your system, because this is what we have to think about: system. We are not talking about one unit. We are not talking about one pipeline, one tank. All of them are associated with other units and linked to other part of the establishment. So we have to think about everything about like as a system. And in a system, check if you change something that, for instance, if you come from analog to digital, how it affects the whole establishment and your whole system, and how it ages, and whether that particular equipment that you change, all the linked pipelines, whether they are prone more to corrode, or whether the joints are the same, whether the material that you use is the same quality, is the same content or not, and then whether that particular setup or new installation, how it will age with time. So if it's all related back to the manufacturer, it's all related to how you install certain equipment in the system, the new parts in the system. Special care is required when upgrading control and instrumentation systems to new digital standards where previously there has been a reliance on analog equipment. I already mentioned it in a way. And report all cases where leakage was discovered and make sure that these events are investigated thoroughly. Leaks are often caused by corrosion and mechanical failure or wear. So these can be indicators that show that there is something in your system that you have to pay attention to. Now, what can I do as an operator? You may be surprised, but a couple of the cases, the topics, of the laws address only a few recommendations for the operators. Why is that? It is basically because of the nature of the topic, such as in this case with aging. Most relevant recommendations and tips are responsibility of the management and responsibility of the process safety engineers and supervisors. And therefore, when it comes to operators, you may have more than this, but these are really important key considerations for operators, what they can do about aging. As you know, when you talk to operators and ask them, what do you think about aging? He doesn't necessarily have to have all the knowledge about that, because he works on the field and he has adequate knowledge about the job that must be done. Aging is such a phenomenon that has a wider meaning, so that's why I highlighted many of the recommendations all together with the management and the process safety engineers. As an operator, you make sure that you have access to installation specifications and that you are knowledgeable in them. As I mentioned earlier, all actually supervisors and process safety engineers must ensure that workers, employees and contract workers have adequate knowledge about the system, and they have access to all the documentations that are necessary to understand what are the circumstances and the hazards, obviously. And report any leaks or damage immediately to the supervisor. And of course, follow all of the procedures and all the aspects that I've already covered in other safety laws. So that was today's safety law on aging. And as always, you can find the PDF version of the safety law in English and in Spanish languages on our website. I put here the link, and also the podcast where with Trish Kerin, director of the iChemist Safety Center, we talk about the safety law. It is also in MP3 format, and you can download it from the website of where it is published. And also I mentioned to you the OECD Working Group on Chemical Accident Report, Aging of Hazardous Installations. This is how you find it. And I would like to highlight also the importance of the guidance document that was published by other institutions, the Energy Institute, the UK Health and Safety Executive, and many other really useful sources of information are available on the internet, and they are for free, most of them. So I highly encourage you to check for more information if you are interested in this topic more in your operation. And where you can find us. So here is our website, the link, the www.iChemistSafetyCenter.org. And as always, I'm uploading this webinar material to the iChemist Safety Center YouTube channel. And I will share also the link on LinkedIn. And you can follow us on different forums such as Twitter, Instagram, and Facebook. So I also encourage you, if you have any questions that I may not be able to answer right now, please feel free to use this email address, thesafetycenter@ichemi.org, to contact us, because we try to answer to your questions immediately. as it is possible. There is a very interesting question whether in both cases that I presented to you, were the operators aware of the respective acid attack risks? I presume they were not, or even if they were, they ignored it. But this is an aspect that you can't see really clearly from the investigation report. What we already know was that the second case, they were not aware of it because obviously they didn't know that it can happen to a concrete pipe. Excuse me. The first case, even though it was a well-known phenomenon regarding oil refineries, and they had a team of experts on corrosion, they just missed to cover it in the hazard identification. They may have known about the aspect because of the other units within the oil refinery. They already had the hazards associated with acid attacks identified. However, this particular unit or pipe session, it wasn't. Oh, my audio is cut again. I'm sorry. I hope it's good now. Okay, there was another oil refinery. I don't want to name it. I'm sorry about that, but it doesn't have. I don't want to expose any companies here, so that's why I'm not mentioning it. But there was another. Sorry, it was a gas plant leak and large LPG explosion, and there is a very good report on the HSE website on creeping changes and pipe thinning over many years due to acid attack on a pipe elbow near a water injection point. That is really, really interesting. I think I remember that case. Another question, with the energy transition, historical data about aging for new processes are not present. Any suggestions on how to tackle this to prevent that lessons learned is the only source of information? Yeah, historical data about aging for new processes may not be present, but I think that hazard identification methods cover quite well this new upcoming knowledge. And so that's how I would establish the knowledge about that. So even if you don't have historical data, you may have a scientific information background about that particular phenomenon, and then you can establish it. Do we have a comprehensive list of aging mechanisms? Oh, there's a lot, actually. I don't know if it's a comprehensive list, but there are many, many experts in the field, and that's why I recommended to check those freely available sources of information reports, really great reports, and you may have a better understanding about those aging mechanisms. All right. There is very important to maintain inspection programs during current global situation, must not use as an excuse. Thank you for that. Somebody asked me to please answer the above question, but I don't find the question. So I try to find the question first, and then I try to answer. How did the acid get into the ground? As I said, the acid was in the tank. So that was how it ended up in the ground, and I assume that that was the tank leaking. Yes, and that is how. Yes, and I answer to your other question, is it an underground pipe? Yes, it is an underground pipe. Thank you so much, everyone, to come today and listen to this presentation. I enjoyed it a lot, and thank you so much for contributing recommendations and further insights. And there is also another one. Integrity and inspection of large storage tanks is very important at the moment, especially if oil or crude is being stockpiled while the oil price is very low. That is really, really true. thank you. This is pretty good. So thank you again, and hope to see you again next week. We will be publishing the registration link, but you can find it already on our website at the www.ichemysafetycenter.org. Thank you so much, and goodbye.